welcome back to our Solvebeta summer question series, and this is for SS2 sequence and series. Now, first, what is a sequence? Let me give an example of a sequence. If you have to complete these numbers, you will simply tell me that the numbers are 6, 7, 8, right? 6, 7, 8. What about this one? You look at it. Oh, to complete this, you would have 12, 14, 16, right? Because you can see that this first number, there's a pattern. There's a rule guiding the increase of the number. The second two, there's a pattern, there's a rule guiding it. The moment you identify that rule, you can tell me the next numbers in this word sequence. So the next number for the first one, I've said is 7, 8, 9. While the second is 12, 14, and 16. That will then give us the definition of a sequence. A sequence is a list of numbers that is following a particular pattern or a rule. It's following a particular pattern or a word rule. That's what a sequence is. A sequence is a list of numbers following a particular pattern or a rule. Now, it doesn't have to be an increasing sequence. It can be decreasing also. Look at this. If I have to complete this, what would be the next 3 terms of this sequence? This is increasing. This is decreasing rather. 10 minus 5, 5. 5 minus 5, 0. 0 minus 5 minus 5. Minus 5 minus 5. Minus 10. Minus 15. Minus 20. So a sequence can be decreasing or it can be what? Increasing. So please take note of that. A sequence can be increasing or what? Decreasing. If you are just joining us for the first time, we have been looking at some topics. This should be our third or fourth class. We've looked at some topics whereby you can scroll and look for those topics to be in sync with us. So take note that a sequence is a list of numbers following a particular pattern or a rule. There's a rule guiding the increase of the numbers. There's a rule guiding the increase of the word numbers. Now, the moment you can get it, it is very, very, very easy to then know the next term in the word sequence. Very, very important. Very, very, very important. And we'll explain that this rule, the first rule is to add 1. The second rule is to add 2. Why this sequence now? The third rule, that's for this third sequence, is to be subtracting 5. Very, very, very important. Very, very, very important. Very, very, very important. Now, we then move to end term of a sequence. The end term of a sequence. The end term of a sequence. If you have this, let's take this one now. 2, 4, 6, 8, 10. Let's take this now. Now, the end term of a sequence is that rule. It's the formula that tells us or that informs us how to get the next term in the sequence. It's the formula that informs us how to get the next term in the word sequence. It's very, very, very important. It's the formula that tells us how to get the next term in the word sequence. It's very, very important. That's the. If I even go to the end term, we're supposed to. So, now let me erase this and go to the next step. Let's go to arithmetic progression. Arithmetic word progression. Now, what is arithmetic progression? AP. Let's quickly get to that. Arithmetic progression. So arithmetic progression. What is arithmetic progression? Arithmetic progression. AP. AP. Arithmetic progression shortened as what? AP. Now what is an arithmetic progression? Arithmetic progression is a type of sequence that the next term is gotten by adding or decreasing from the previous term. It's gotten by adding or decreasing from a previous term a particular constant. Arithmetic progression is a sequence such that the next term is getting by adding or decreasing from the previous term a particular constant. That is an arithmetic progression. Now, I'm going to give you that same example. This example 2, 4, 6, 8, 10. Now, this is an arithmetic progression. The next term is gotten by adding or decreasing the same number from the previous term. To get 4, we add 2 to this 2. To get 6, we add the same 2. To get 8, we add the same 2. To get 10, we add the same 1, 2. That's what makes it an arithmetic progression. Mind you, there are other sequences that you do not add the same term. You add different terms. Look at this sequence. 2, 3, 5, 8, 12, 17. Now look at this. This is not an arithmetic progression. Why? Look at this. What is the rule there? 3 minus 2 is 1. This 1 was added to this 2 to get this. Then 5 minus 3 is 2. 2 was added to this 3 to get 5. 8 minus 5 is 3. You can see that the number being added is increasing. So what do you add to this one is 4. What do you add to this one is 5. Now you see this is a sequence, but it's not an arithmetic progression. Why is it not an arithmetic progression? It's not the same term that is added to the previous. It's not the same constant. It's not the same number that is added to the previous to get this. Unlike this one, this is an AP. It's just 2 that is being added. It's just 2 that is being added. But this one, what is being added to the previous term to get the next term is increasing by what? 1. So there are sequences like this and there are sequences like this. This type of sequence is known as what? Arithmetic progression. Arithmetic progression, the next term is gotten by adding or subtracting a constant. That means a number that does not change. Adding or subtracting a number that does not change to the previous term. To get the next term, I will add the same number to the previous term. To get all the terms in this sequence, I will add the same number to the previous term, unlike this one. So please take note. This is an AP, arithmetic progression, while this is not an arithmetic progression. Very, very important to note the difference between an AP and the one that is not an AP. Although they are both sequences, but one is an arithmetic progression, the other one is not. So let's go back to this 2, 4, 6, 8, 10. Okay, we can just continue like this and so on and so forth. Now the first term of this sequence is A. The first term is denoted by what? A. The first term is denoted by what? A. There's a formula to get any term in this word sequence. Now, how is the formula derived? Look at it. If the first term is A, the difference, that's the constant, the same number that is added to get the next term, is known as the common difference. It's known as the common difference. It will be this minus this, 4 minus 2 or 6 minus 4, because it's the same for because it's the same way it's gotten. You can say the difference, common difference is 4 minus 2, or you can say it's 6 minus 4, or you can say it's 8 minus 6, or you can say it's 10 minus 8. Common difference, let's say 4 minus 2. The common difference is what? 2. So it therefore mean that to get, let's say this is the first term, let me call it T1. Let's say this is the first term in this sequence 2. To get the second term, you say A plus this common difference D. 2 plus 2 will give you what? 4. Right? right? I don't know whether you are following it. Now, to get the third term, you can say it is a plus, to get this third term now, 6a plus 2d. Why is it a plus 2d? 2 times the common difference 4. 4 plus 2 give me 6. You know the common difference is 2. 2 times, I put this constant 2 because this 2 times 4 is what? Sorry, 2 times this d2 is what? 4. Then 4 plus a 2 is what? 6. So to get the fourth term, you can see it's a plus 3d, a plus 3 what? D. 2 plus 3 times 2, 2 plus 6, 8. The fourth term, not 8. So but we can say that the end term of an arithmetic progression is given by a plus this. Now this d, the coefficient of this d is increasing by 1, abi? Decreasing by 1, abi? Now it's increasing by 1, but if you notice, for the fourth term it is 3, for the third term it is 2, for the second term it is what? 1. So we can say that the end term is n, this n, abi, and the coefficient of d is what? 3. Subtraction of 1. This is n3. The coefficient of d is 2. So we can say this n here, while this one is n minus 1. 4 minus 1. This d is 4 minus 1, 3. N here. This the coefficient of d is 3 minus 1. So we can call this the formula for to find any term in an arithmetic progression. This is the formula. So from this now we can be asked to find the 20th term. If I have to find the 20th term of this progression, the 20th term, the importance of this formula is that we might not know, we might not be given, in fact, we can just be given 3 terms of this arithmetic progression. We can be asked to find the 100th term. So how do you find the 20th term? It's very simple. You say Tn, you must memorize the formula, is equal to a plus n minus 1 times d. So what is Tn now? The 20th term. A now is still the same. 2. 20 minus 1, 19. 19. Just like T4 is 3D. 220 will be 19D. What is D? D is the common difference. D is constant. The common difference should be what? 2. So you have T20 is equal to 2 plus 19 times 2 should be 38. 2 plus 38, right? So the 20th term is 2 plus 30, which is what? 40. You can do that. You can try it. You can try it. You can add 10, 12, 14. When you get to the 20th term, it will always be 40. It will always be what? 40. This formula works. Now let's look for another one. Find the let me say the 100th term. Find the 100th term. 100th term. See the same formula. This formula we're going to use. Tn is equal to, I'm not going to write the formula because it's already here. Tn is equal to a 2 plus n is 100. 100 minus 1. What is d? D is the same, 2. So this will be 2 plus 99 times 2. What is 99 times 2? 18, 108. 99 times 2 is 108, right? 2 plus 108, which is 110. So it means that the 110 is 1 what? 10. The 110 is 1 what? 10. Wait. Sorry. 2 times 9 is 18. 1. 2 times 9, 18 plus 1, 19. Sorry, that's a mistake. Sorry, please forgive me. 2 times 99 times 2, 18, 1. 18, 91, 9, it is 198. So the unit term is 200. 198 is 2 what? 100. So it's 2 what? 100. It's 2 what? 100. 200. The reason why I was able to figure that out easily is this. This is why I was able to figure it out. Now there's something called the end term. I was able to figure out that this is wrong. There's something called the end term of an arithmetic progression. Now what is the end term? Let me rub this off. The end term is that formula that tells us or that gives us each of the term of this specific sequence. Now this formula gives us every term in any sequence. This formula can tell us the what's it called? It can tell us maybe the first term, the second term, the fourth term. It can tell us any term of any arithmetic progression. Any arithmetic progression you are given. But the n term is specific to this arithmetic progression. It tells us the n term. It tells us so number of terms of this particular AP. And let me show you how to get the n term. The n term, the nth term. Now to get the n term, look at it. The n term will be, this is the formula, Tn is equal to a plus n minus 1d. Now to get the n term, what you simply do is this. Please look at it. The n term, you just substitute a to be 2. Now this n, you leave it, it will remain n minus 1. And what is d? D is what? 2. Are you showing that? So this is 2 plus 2n minus 1. Oh, sorry, 2n minus 2 times n is 2n, minus 1 times 2 is minus what? 2. We are trying to get the n term. To get the n term, you will not substitute any value for n. You just leave n alone. You substitute the value for a, which is 2. You substitute the value for d, which is what? 2. But you leave n alone. So 2 plus 2 times n, 2n, 2 times minus 1 minus 2. So you have what? When you collect that time, 2 minus 2 plus 2n. So 2 minus 2 is what? 0, 2n. So it means that the n term, you get the n term is 2 what? N. To get any term in this sequence, just multiply 2 by the position of the term you are looking for. That's why I could know that the 100 term cannot be 108. The 100 term, you can use formula to get the 100 term. The 100 term will be what? T100 will be what? 2 times n, and there is 100, which is what? 200. To show that that is correct. To get the 20th term, just like so let's prove it. To get the 20th term, it will be 2 times n. What is n there? 20. We're looking for the 20th term, which is what? 40. So this formula gives us the position, the term in any position in this particular arithmetic progression. It might not work, it will not work for any other AP. It might not work for any other AP, but it will always work for this what? AP. This is the general formula to get the n term of all APs. Why is the specific formula to get the n term of this what? AP. And this specific formula is gotten from this what? AP itself. I don't know if you got that. You can rewind, you can watch again, listen to it again and again and again for you to comprehend. So let's take another example. Let's take another example. Let's take another example. Let's take this example. Let's take this example. Okay, let me take this example 2. Find the 5th, 10th, and nth term and nth term of the AP. Now, in case they are not told that is AP, you can know whether it's AP by checking the sequence if it is increasing or decreasing by the same number. You can know that. Although you will most likely be told that is an AP. But if you are not told, you can check the sequence. Is it decreasing or increasing by the same number? Look at this one. It's increasing by the same number. So you can know that, oh, it's an AP. It's an AP. So now, let's go to this. We want to find the 5th term of this AP. Number 1, T5. T5. What's the 5th term? First, what's the n term? The n term is formula a plus n minus 1 what? D. So it will therefore mean that T5 will be a is what? 5. The first term, a is the first term, 5. Plus n. What is n? The 5th term we're looking for. 5 minus 1. What is d? The common difference. The common difference, you can subtract a previous from this term. 10 10 minus 5, which is what? 5. So T5 now will be what? 5 plus 5 minus 1 is what? 4. 4 times 5. 5 plus 20, 25. The fifth term is actually the next term because it's the first, second, third, fourth, and you see that it's 25. Consider it's 25. Now let's go to the second one here. The 10th term, T5 is equals to A 5 plus 10 n minus 1 what? GD is what? Also 5. So it's 5 plus 5, 9 times 5. 5 plus what? 9 times 5, 45. So 50. So the fifth term is what? 50. Sorry, the 10th term is what? Ah, they are right. So this is 10th term. The 10th term, that's what we just look for because n is 10. The 10th term is what? 50. I'm very, very sorry for that. 10th term is what? 50. The 10th term is what? 50. Now, let's look for the nth term. The nth term will be, let me take this slowly. To get the nth term, what you do is just go back to this formula, leave n alone, Tn, sorry, leave n alone, Tn is equals to A is still 5, and leave n alone, n minus 1, d is still what? 5. Then let's solve for that. 5 plus 5 times n, 5n, minus 1 times 5 minus 5. So you have 5 minus 5 plus 5n, which is what? 5 what? N. So the n term is what? 5 what? N. The n term is 5 what? N. Let me look for an example that is a decreasing AP. The AP is decreasing. Let me look for a decreasing AP. Before I move on to something, let me look for a decreasing AP. Okay. Look for a decreasing AP. I can rub this off for the example. Let me look for a decreasing AP. Now look at this. Look at this first one. Minus 10, minus 8, minus 6, minus 4, minus 7, minus 6. Now let's look for the find the 9th term and the nth term. Find the 9th term and the nth term. So what's the formula to find any term? A plus n minus 1 what? D. So we want to find the 9th term. Now what is A? A is the first term here, minus 10 plus, what is n? We're looking for the 9th term, 9 minus 1. Now what is the common difference? Now please be careful. If you have a negative sequence like this, how do you get the common difference? It's not that hard. You see, this minus 8 here, minus 10. Be careful because there are a lot of minus there. Minus 8 minus 10. Remember the second minus the first, or the third minus the second, and so on and so forth. So you have minus 8 plus 10, which is what? 2. 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 Are you seeing that? Minus 8 plus 10. Minus 8 minus 10, which is what? 2. So it means that D is what? 2. D is what? 2. So you have what? Minus 10 plus 9 minus 1 is what? 8. 8 times 2. So you have minus 10 plus, this is 16. 8 times 2 is what? 8 times 2 is what? Minus 10, 9 times 1, 9 minus 1, 8. 8 times 6. What is minus 10 plus 16? That should be 6. So it means that 9 term is what? 6. 9 term is what? 6. 9 term is what? 6. You can try it. Minus 4. This is minus 2. 0, 2, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see. You can see that's correct. Now, the end term. How do we then get the end term of this? The end term. Tn. This is the first. The second Tn will be the same thing. The same way we did the previous one. A minus 10 plus. Remember, you're looking for the end term. You don't substitute any value for n. You leave n as it is, minus 1. What is d? 2. So you have minus 10 plus 2 times n, 2n minus 2. That's the reason why I gave this as an example, because I wanted to show you the difference. So this will be minus 10 minus 2 plus 2n. Now, unlike the previous one where this will always cancel out, we have minus 10 minus 2, which is what? Minus 12 plus 2n. So which is 2n minus 12. If we are to, we cannot cancel this one because it's minus 12. Now if we are to write this properly, we write the positive term first, 2n minus what? 12. So this is the nth what term. Let's check if it's correct. The ninth term, let's use it to get the ninth term, T9. Remember, this nth term is the formula that gives us any term in this specific what? AP. So T9 will be 2 times 9 minus 12. What's 2 times 9? 18. 18 minus 12. So you see, 15 minus 12 is 6, right? You see that this one is correct. Give us the specific term we're looking for. You see that is correct. So that's it. Now there's a question here. There's a question here that says, find which term is the 90th of this AP. Find which term is the 90th. Find which term is the 90th. Find which term is the what? 90th. Find which term is the what? 90th. So we want to find which term is the 90th term of this what? AP. Okay, rather, that's not the question. It's not find which term is 90. Find which term is 90 in the AP. Yeah, find which term 90 is in the AP. There are two different things. Find which term 90 is in the AP. Yeah, remember that's why I brought it. Find which term 90 is in the AP. That means there's 90, there's the number 90 in this what? Arithmetic progression. That means minus 4 down to 90. We now want to find which position 90 is. You know, minus 10 is the first position in this AP. Minus 8 is the second position. So we are looking for the position that 90 is in this AP. That means if we write this number down, we'll get 90. So we're looking for the position of 90. That's the question. It's not find the 90th term. If we have to find the 90th term, we'll use this and we'll get 90. But we are told that find which term 90 is, which position, which term. You can substitute term with position. Which position is 90 in this AP? So how do we do that? It's very easy. Using the same formula, Tn is equal to A plus. It means that we're looking for n. So the term 90, the term is 90. The term is what? 90. So Tn will be 90. Just like here, we got T9 to be 6. Tn here is what? 90. The term is 90. 90. Tn is 90 because the term is 90. Where they have Tn to be 90 is equals to minus 10 plus. Now, n will be left alone. N minus 1, d is what? 2. N will be left alone because we're looking for the position of this 90. Tn, 10. We're looking for this position. So 90 is equals to minus 10 plus 2 minus 2. So we have 90 is equals to minus 10 minus 2 plus, oh, this is 2n. 2 times n is 2n. 2n minus 2. 2 times n, 2n. 2 times minus 1 minus 2. So minus 10 minus this 2 plus 2n. Let me move here. So you have 90 is equals to minus 10. When we minus 10 minus 2 is minus 12. So let me just write that. Plus 2n. So when we bring this one, you have 90 plus 12 is equals to what? 2 what? N. So what is 90 plus 12? And that should be 102. Is it 102? Yes. 102 is equal to what? 2 what? N. 2n is equal to what? 102. So divide both sides by 2. N is equal to 51. 50 what? 1. So n is 51. And if you check, If you check T51, let me use this n term. T51 is 2 times 51, 2 times n minus 12 minus 12. I want to use this formula for n term to check if truly the 51 term is what? 19. 2 times 51 is what? You can see that it already looks like this. 2 times 51 is 102. 102 minus 12 will give you what? 90. You can see that the 51 term is what? 90. So we'll just use this formula for AP to get the position of 90 in this what? AP. Very, very, very what? Simple. Very, very, very what? Simple. Very, very, very what? Simple. Now finally, let's look at this under AP. Let's look at it under AP. Then, after looking at this, I'll give you something to do. Let's look at this finally. The seventh term of an AP is 22, and the 30th term is 91. Find the 50th term. Find the 50th term and 2 the nth what? Term. So look at this. The seventh term of an AP is 22 and the 30th term is 91. You have to find the 50th term and the n what? Term. Now anytime you have a question like this under AP, it will lead you to a simultaneous equation. Why? Why? Basically, we're not giving the what's it called? The AP, the members of the AP. That's the numbers in the AP. We're also that a position, this position has this term. This position has this term. Find another term in that what? AP. So anytime you have something like this, it will lead you to a simultaneous equation, and your simultaneous equation, your understanding of simultaneous equation must be sound. It must be very, very what? Sound. So let's go ahead. It says the seventh term is 22. So we interpret it first. Don't forget that the n term is a plus n minus 1 what? D. So the seventh term, T7, is 22. Those T7, that T7 is 22. T7, don't forget it's T7. T7, the seventh term. A plus any of the 7. 7 minus 1 what? D. A plus what? 7 minus 1, 6 what? D. So this first statement has gotten us this what? Equation. So now we'll go to the second statement. The 30th term is 91. So T30, that the 30th term, we have been giving it to be 91. 91 is equals to A unknown, we're not giving. N is what? 30. 30 minus 1 what? D is unknown too, because we're not told. 91 is equal to A plus 30 minus 1 is 29. 29 what? D. So we have what? Equation 2. We now have to solve this equation simultaneously. A plus 6D is equal to 22, and A plus 29D is equal to what? 91. So we have to solve this equation simultaneously. So now, how do you solve this simultaneously? We can say, since A is here, we can use elimination. We say equation 2 minus equation 1. Simultaneous equation. Equation 2 minus equation 1. So if we subtract 1 from 2, A minus A will give you 0. 29D minus 6D will give you 23D. 29D minus 6 will give you 23D. 91 minus 22. What's 91 minus 22? 91 minus 22. 8, 9, 79. Is that 69 rather? That's 69. So you have 69. So what I've done is to subtract each, this minus this, A minus A, 29D minus 6D, 91 minus 22, because I said to eliminate A. I did that to eliminate A because I knew that A minus A will give me 0. So when I subtracted equation 1 from equation 2, I got this as the new equation. So from this, I can get D to be 69 divided by 23, which is what? 3. So D is what? 3. So I've gotten the common difference to be what? 3. Now, since the common difference is 3, I can now substitute the common difference in any of this equation to get what? A. So let me substitute it in equation 1. Substitute in equation 1. So let me substitute in equation 1. This equation 1, a plus 6d is equals to 22. So if I substitute, you have what? A plus 6 times 3 is equals to 22. A plus 9 is equal to what? 22. A will be what? 22 minus what? 9. What's 22 minus 9? Oh, sorry, there's a mistake somewhere. 6 times 3 is not 9. 18 is 18. Yes, it's 18. Sorry, it's 18. Let me go back there. A plus 6d is equals to 22. So a plus 6 times 3, 18, is equals to 22. A is equal to 22 minus 18. A is equals to what? 4. So the first term is 4, and the common difference is what? 3. The first term is 4, and the common difference is what? 3. A is 4 and D is what? 3. I can now use that to get this question. I cannot find the n term without getting A and what? D. So let me rub this off. You can write, let me rub this off. And let me rub it off to get the n term. Question 2, the n term Tn is equal to A plus n minus 1 what? T. So Tn, which is what we're looking for, is equal to A. Oh, A is 4. 4 plus n. What is n? Unknown, because we're looking for the n term. Minus what is D3? So you have 4 plus 3n minus 3. 4 minus 3 plus 3n. You have 1 plus 3n. So this is what will give us the n term. This is the n term. This is what will give us any term in that what? AP. So that's it. Now do this for me. Do this for me quickly. Do this for me. I hope you're beating this. Now do this for me. Then we'll continue in the next class. Do this. I'll give you 3 questions. Just 3. Number 1, 5, 8, 11. Find number 1, 15th term, 2, 50th term, 3, nth term. So number 2. The 8th term, this marker is not working up. The 8th term of an AP is 38, and the 12th is 58. Find the 30th term. The 8th term of an AP is 38, and the 12th term is 58. Find the 30th term. 2, nth term. And let me give you something. I'll test you. Just like the one I gave you. Let me see it. Find which term 190 is in the AP. Find which term 190 is in the what AP. So 190 is a term in this AP. You're looking for the position. So we'll continue in the next class. Bye.